I see we have a little background noise. They're picking up the leaves again out there. Okay, well, in section 10.3, and again, today we're recognizing Jaime Escalante, where his famous statement was, "Hay que tener ganas." You have to have desire to want to get some stuff, and again, you can build your own desire. It doesn't always have to come all by itself. You have that desire. Okay, for number one, we're looking for a technique in which, as we simplify this, to divide this radical into two parts. We're looking for a perfect square factor of 45. And the perfect square factor happens to be 9. 9 times 5. So if you multiplied these, you would get that. But now that you've picked out a perfect square factor, this becomes 3, the square root of 5. And I should show you the fellas right outside my door here. There they are. They're blowing some leaves. And we're doing the best we can. I didn't want to think I was kidding about picking up the leaves. Okay, so for this one, you want to sort of divide it into two parts, the square root of 3 over the square root of 81. And we know the square root of 81 is 9, and the square root of 3. Now in number 3, we see 7 times 7 is 49, and the square root of 49 is 7. So that comes out of the radical, and we have left under the radical sign xy. You could have put it yx. Usually we put it alphabetically. And then here it's going to be the third root of 70. Now, is there a perfect third root factor in 70? And the answer is no. So that's the answer. Now, as we get into some of these others, I'll try to show you the technique that's very useful. Here the negative sign stays out. We want to set up two radical signs, under which one will put all perfect square factors. So for 27, it's going to be 9 times 3. It is a little noisy. I may have to shut it down. And then we have b cubed is a, let's try b squared there, is the perfect square. And then what am I left now? I'm left with an a, and I'm left with a single b. So once again, if I multiplied these, I would get that. But what I want as a technique for doing these is to put some perfect squares under this radical sign, and then everything that's left as factors over there. So this becomes 3b, the square root of 3ab. Now that would be pretty good, but not correct, because I have to be sure to bring that negative sign down there. And I think I'm going to take a break. Okay, the leaf blowers are away. And now we're looking at, again, simplifying section 10.3, number 6. And we want to develop a strategy for doing this. Well, we said a good way is to bring this into two sets of radical signs where we're looking for a perfect cube factor of 16. Yep, 8. And then on the bottom, this happens to be a perfect cube. So then the cube root of 8 is 2. The cube root of 2 over the cube root of 27 is 3. Now, an interesting thing happens in number 7 here. because if I take this and divide it by 2, and let's just do that, same technique. We want to put all the perfect cube factors under this. Well, this becomes 27 times 2 that I would normally put over there. But if I take a 2 out of here and I put it there, 2 times 4 is 8. 8 is a perfect cube as well. So we can think of it sort of like that. And then now x to the first, x to the third, that gives me x to the third. And this gives me y to the sixth. I guess I don't need this one at all. So by bringing this 2 over here, I get x to the third. Y to the fifth and a 1 gives me y to the sixth. These are perfect cubes. This is a perfect cube. So the cube root of this is 3. The cube root of this is 2. And the cube root of this is x. And the cube root of this, remember dividing the 3 by the 6 by 3, we get y to the second. And 2 times 3 is 6, x, y to the second. Again, if I was doing this on paper instead of front of somebody, I might have done it a little different way, but again, I'm trying to show you some technique here. It looks a little bit tedious, anyway. Okay, now for number 8, remember the negative sign. And our denominator, we know the square root of this is going to be y to the fourth. So we could just do that. And this is going to be the square root of, divide that by 2. That's going to be 64 times the square root of 2. Again, this times this gives me that, 2x. We're looking for a square root factor of that to isolate, so we can take the square root. So this then becomes a negative 8, the square root of 2x over y to the fourth. Okay, continuing, we want to set up 2 sets of radical signs. And under one radical sign, we're going to put all the perfect fourths there are as a factor. So this will be x to the 8th is a perfect fourth, and we have an x left over. And then y to the 16th, since it's a multiple of 4, is a perfect fourth. So this then becomes, we take away the radical sign, x to the second, y to the fourth root of x. Now again, as you look at this, this is a perfect square. So this is going to be 11. And a to the fourth is a perfect square. So that's going to be a squared. And then what's left over is the square root of b. Now again, I didn't use this technique. If it's obvious, you don't need to do that intermediate step. Now for number 11, a new technique, you can put this all under a common radical sign. and 7 will go into there once, 7 will go into there 4 times. X cancels out and you end up with, under the radical sign, 4x squared. Again, this becomes a 2. And the square root of this is 4x. Okay, and again, there's a couple of ways to do things, and let's put all this together first. So this is going to be the fourth root. 3 times 12 is 36. And then we have x to the fourth, y to the third. Okay, we brought this and integrated it. Now, when you look at 36, is there any number? Let's take a look at that. As I was saying, is there any number that is a perfect fourth factor of 36? And if you're not sure, a technique might be to put 36, find its prime factors. And there's a 2 times 2 times 3 times 3, but there's no perfect fourth. But there is one in y to the fourth. So this is going to become the fourth root. Well, let's take out what we can first. X, then the fourth root of 36 y to the third. Now I made a little error when I copied the problem down, but that's a good example anyway. All right, in number 14, again, we're looking for perfect fourths. Now I don't know if you recognize it, but 625 is the perfect fourth of a 5. 5 times 5 times 5 times 5 is this. And this is a perfect fourth, and I looked it up, of 7. Now, this y comes to the top as a, what I have under there, I'll just put it there temporarily, x to the fourth times x to the second, y to the second. So my x to the sixth, I broke up into x to the fourth times x to the second. So I could take out then 5/7 x, one of these x's, and then what's left under the radical sign is x squared, y squared. This is technically right, but it's not really simplified as much as it should be. So if you took away the radical sign, this becomes 4 over 2, which is 1/2. So this should be the square root of x, y. So the final answer, 5/7 x times this. I didn't simplify this enough. Okay, they are getting more difficult, and I'm going to just outline how we do it. So here was the original example with a negative exponent in the index number. So I took this and put it underneath in our denominator, so the sign of this exponent, index number, became positive. Then I rewrote it all under one common radical sign. And then I simplified. So I brought the 2 down, and that became a 5. Remember, there was a 1 still up there in the denominator. Brought the b to the third down, that became a -3, and that left me with this. Now I took the 5th root of 1, which is 1, and the 5th root of a to the 5th, which is a, and I'm left with the 5th root of b under the radical sign. So that is the answer. And then number 15, we went back to the previous section where we said, well, we have different index numbers, but we can deal with this if we convert it to its radical fractional form. And now, this is our bigger fraction. So our common denominator, remember there's the 1 that we keep up there, our common denominator is 12. So I multiplied this by 3, multiplied this by 3. That gave me my 21 over 12. Multiplied this by 4. This gave, when I brought it down, became a -8 over 12. So I'm just about ready to finish this one up. This is going to be 1 over a to the 13th 12th. When I do this subtraction, this is what I get. But they want an answer in radical form, so this then becomes 1 over the 12th root so it's the 12th root index number of a to the 13th, but I can actually simplify that more, and that wasn't in their answer book. You could take out one of the a's, and you're left with a to the first under the radical sign. So this is the answer they gave me in my answer key, but I think this is one even better. Again, it's challenging. Again, these problems are more challenging, but if you do it built on the things we've had, I think they're manageable. So here we see index number 2, index number 3, index number 6. So going to our fractional exponents, converting this to x to the 3/2, 3 over 2. This one, x to the 2/3. And this one, x to the 5/6. And now you have a case of just adding up the exponents. Well, this has a denominator of 2, 3, and 6. Common denominator is 6. So to make this a 6, I got to multiply it by 1 in the form of 3 over 3. This one by 1 in the form of 2 over 2. So 3 times 3 is 9. 2 times 2 is 4. And we just bring our 5 down. So this now becomes x to the 18th over 6. And that's pretty easy. X to the 3rd. Wow, all of this reduces to this if you know the technique of doing it. All right, number 17, as I look at this, this is a perfect 5th there. So I could take the 5th root of 32, happens to be 2. And I could take the 5th root of x to the 9th, that's going to be x to the 5th, comes out as an x, and then under the radical sign, I'm left with the 5th root of 4, x to the 4th. So I divided this into x to the 5th times x to the 4th. So I took out the x to the 5th, that gave me my x here. And then I'm left with x to the 4th under the radical sign. Now this one is a perfect fifth. This happens to be a 3. And this with the negative exponent is actually just going to go up to the top here as y to the 4th. Oh, how about y to the 3rd? There you go. Just bring it up to the top. And that's the answer. Some of these, again, get to be quite tedious. This one's not too bad. But here we started off with 6 over 3 as whole numbers. That just became 2. 2 over 1, but we don't need the 1. Now I put all of this under the common radical sign. And 5 goes into 80 16 times. I brought my x to the negative 1 up. It became a positive 1. That gave me x to the 3rd. So now I don't have anything in the denominator anymore. Now, I have here 16. Is there a perfect cube in 16? Yes, 8. 8 times 2. And x to the 3rd is a perfect cube. So here's where we are. We want to take the cube root of this, which will be 2 out there, times 2x. Taking the cube root of this is 2x, times the cube root of 2. And then 2 times 2 is 4. So this becomes 4x, the cube root of 2. All of this to get there. Now, number 19 was tedious, and it took me a while to do it, and I didn't want to have to do it all live in a sense, so I've worked it out. I changed this from its radical form to its fractional exponent form. And then I wanted to combine like terms. So I had to have common denominators. Well, here they were all 4, here they were all 6. So my common denominator was 12. And then I had to modify these fractions so they became a 12, and that's what the red indicates. So here I am with 2 times 3 is 6, 9 times 2 is 18 over 12. Then 6 times 3 is 18, 2 times 3 is 6 over 12 for my y's, and then 18 plus 14. I added my numerators and I got this. Well, 24 divided by 12 is 2, x to the 2nd. 24 divided by 12 is 2, y to the 2nd. Now here, this part was a little tricky. I divided that fraction into 2 parts. 12 goes into there twice, and I'm left with 8 twelfths. Well, 8 twelfths reduces to 2/3. So I had 2 and 2/3. So I took out z to the 2nd for that one whole 2 there. And then I converted 2 over 3 to the radical 3, the square root of z to the 2nd. Wow. Lots of stuff there, and it took me a while to do it, but again, I don't want this tape to be too long. One more to go. Okay, number 20 looked like this originally. I put it under one radical sign. Now I can cancel out the 3, goes there. This goes 32 times. Cancel out that, this becomes a 10. And then I bring up my -4, becomes b to the 8th. So this is what I have as my next step. Now I happen to know that 32 is a perfect fifth. So this comes out here as a 2. A to the 10th becomes a to the 2nd as I divide the 10 by 5. I can take one b out. That would be b to the 5th. I'm left with b to the 3rd that I'm going to write as the 5th root of b to the 3rd. And again, some of these are tedious, but follow the protocol of what we've done, and good luck.